Today, we're plunging into one of those really foundational decisions you face when building software. Monolithic versus microservices architecture. Basically choosing between like one giant program doing everything or a whole bunch of mini programs working together. We've spent a good bit of time wading through sources for this deep dive, and well, it's become super clear just how much this choice hits everything. Development speed, how often you can deploy updates, system resilience, even, the operational costs down the line. So our mission today is to unpack with you what really fits. What fits your project's complexity, your team size, your long-term goals for scaling. Because honestly, what we found is it's never really about which one's better. It's always about the right fit for your needs.
That's such a crucial point. It's not just some tech preference, it's really a strategic business decision. It has these huge long-term ripples. Let's take a practical example right off the bat. Think about a classic e-commerce website. If you build that as a monolith, well, you'd have the UI, the product catalog, payments, orders, all bundled together, tightly coupled in one big code base. Now, for getting started, especially in MVP, a minimum viable product that all in one structure, often the quickest way. Simple. It's sort of a bet on reducing human coordination when your team's small and maybe the budget's tight. Okay, now contrast that. Same e-commerce site, but using microservices. Here, you'd maybe have one service just for logins, user authentication, another for the product catalog, a third just for payments, each one built, deployed, scaled totally independently. And the real power isn't just the tech decoupling, it's organizational decoupling too. Lets you scale teams independently. Each small team can almost be like its own mini startup. Target's cart service is a great example. Big holiday sale. They can just scale up that service, the cart, without messing with, say, product recommendations.
Okay, so if we cut right to the chase then, the basic difference is monoliths lean towards simplicity, speed, especially early on. Microservices prioritize scalability, flexibility, and letting teams move fast independently, more for the long haul.
Right. Exactly. That's the core trade-off.
All right, let's really understand this all-in-one monolith thing first. Maybe the easiest way to picture it is like building an application as one single self-contained skyscraper. The UI, the business logic, the database stuff, it's all one unified chunk of code. Develop, manage, deploy together. So like a new social media app built as a monolith. User profiles, newsfeed, messaging, they'd all live together in that single application. One code base, one runtime. Sounds wonderfully simple, doesn't it?
It absolutely is initially. And that unified nature, it brings real upsides, especially if you're a startup aiming for that MVP. With that single code base, a small team can, well, they can build and ship something that works incredibly quickly. They don't get bogged down right away with distributed system complexities. Development itself is simpler. Writing code, debugging, rolling out features,
Yeah.
it's easier. You can literally trace a user request through the whole system in your IDE, your coding tool. No need for fancy distributed tracing tools early on. Deployment, pretty straightforward. Package it up maybe as a JR or a WAR file if you're using Java. Move it to a server. Done. You don't need like a specialized DevOps team or complex tools like Kubernetes right at the start. And testing. End-to-end testing is way more direct. The whole application context is right there. You can test flows across multiple features without faking or mocking other services over network. So yeah, for new projects, small teams, a monolith is often just the most pragmatic choice. Less initial complexity means faster time to market.
That speed and simplicity. Yeah, that sounds like a superpower for a startup.
Yeah.
What's the catch? There's always a catch, right?
Yeah.
Do those downsides start creeping in as the project grows? Because that initial simplicity, the thing that makes it so attractive, it kind of plants seeds for future problems, doesn't it? As that monolith gets bigger, that simplicity can morph into rigidity. Everything's so tightly coupled that changing one tiny part means you have to retest and redeploy the whole thing. And that can really, really slow down development cycles. Imagine like a tiny update to the payment module forces a full regression test of the entire e-commerce platform. Suddenly, you're looking at month-long release cycles instead of pushing updates daily or weekly. Ouch.
Oh, it often gets worse than just slow. That tight coupling creates a single point of failure. A critical bug, maybe in something not even essential like a product recommendation engine, could potentially crash the entire application. That's a huge risk for any business relying on its software being up. And beyond just crashing, you get locked into one technology stack. Say you built it all in Ruby on Rails, deciding later to use, I don't know, go for some high performance part. That means a massive rewrite usually. Then you hit these scalability walls. Scaling becomes super inefficient. If just one part is getting hammered with traffic, you have to scale the whole application. That means higher costs, more resources than you need, and potential bottlenecks managing traffic inside that big monolith. These exact problems are really what pushed the industry towards looking at microservices.
Okay, so that makes sense. When that giant application starts growing under its own weight, that's where microservices come in. They're designed to break up those big clunky systems into smaller independent pieces, right? Services, like that ride-sharing app example. Instead of one huge code base, it gets split. User logins are one service, ride matching, another, GPS tracking, a third, payments, a fourth. Each one runs on its own, talks to the others through APIs like REST or gRPC, these defined communication channels.
Exactly. That separation, that modularity, that's the whole game. It means one part can be updated or scaled up or down without touching anything else. It's just a world away from those high-stakes, all-or-nothing monolith deployments. The key advantages really stack up. First, independent scalability. You scale just the services that need it, like boosting the ride matching service during rush hour without affecting anything else. Saves resources. Then there's improved fault isolation. If one service fails, maybe the promo code service has a bug, it doesn't necessarily take down the whole app. Users can often keep doing other things. Techniques like circuit breakers help here. They're like automatic fuses, stopping a failure from cascading. And finally, technological freedom. This is a big one. Teams can pick the best tool for their specific job. Maybe go for that speedy GPS tracking, Python with Django for user profiles, whatever fits best.
Yeah.
So the core advantage boils down to decoupling. It lets teams develop, deploy, scale independently. That fosters faster innovation and makes the whole system more resilient.
And we've seen this play out with the big tech companies, right? The ones facing just massive growth. Uber's transition is a famous case. They went from a single city monolith to a global platform by breaking it down. Ended up with hundreds of microservices, allowed teams to work in parallel, deploy independently. Amazon too. Their retail site isn't one app. It's this incredibly complex web of hundreds, thousands of individual microservices. That's how they can constantly tweak things, add features, with almost zero visible disruption to us users.
And that architectural shift, it profoundly changes how teams work. It aligns really well with that two-pizza team idea. You know, a team small enough to be fed by two pizzas. A small autonomous team owns their service end to end. Development, deployment, maintenance, build it, run it. That breeds a really strong sense of ownership and deep expertise. Now, of course, it's not all sunshine and rainbows. This model brings its own challenges, things like keeping data consistent across different services, dealing with network delays between services, setting up service discovery so services can even find each other. These are real complexities you have to manage. But for companies hitting that monolithic growth ceiling, these are often problems worth solving for the scale and flexibility you unlock.
Right. So when we move past the sort of high-level pros and cons and do a real head-to-head comparison, it really comes down to specifics. The choice isn't about which is better in theory. It's about the pressures and goals of your specific project, isn't it?
Absolutely. Let's break down those key differences maybe a bit more directly. Codebase, monolith, single, unified, microservices, multiple, smaller code bases, one per service. Pretty clear. Deployment. Monolith, the whole app goes out as one unit. Microservices, services deploy independently, big difference there. Scalability. Monolith, you scale the whole thing, even if just one part is busy. Microservices, you scale individual services, much more resource efficient. Technology stack. Monolith, you're pretty much stuck with one. Microservices. Tech diversity. Teams pick the best tool for their service. Fault tolerance. Monolith, lower. One bad bug can potentially crash everything. Microservices. Failure is usually isolated. One service fails, others keep going. Team structure. Monolith often leads to larger teams, maybe siloed by function. Microservices enable those small, autonomous, end-to-end ownership teams. And finally, complexity. Monolith is simpler to get started with, develop, deploy initially. Microservices. Definitely more complex to set up, manage, monitor because everything is distributed.
Let's drill into that complexity aspect, especially around development and deployment. You said the monolith is faster to start with. Everything's in one place. A small team can get moving fast. No wrestling with network calls between services or figuring out distributed transactions right away. Deploying is simple at first, too. Build one artifact, push it out. Easy. But that initial simplicity hides that trap, right, as it grows. That all-or-nothing deployment becomes this high-stakes, really nerve-wracking event. A tiny change needs a full redeploy. Risk goes up, release speed tanks.
Exactly, and microservices. They feel way more complex right from the start. No doubt about it. You're not just writing code, you're engineering a whole system of services that need to talk reliably. That means you got to get your hands dirty with things like robust CI/CD pipelines, automating build, test, deploy. You need container orchestration, probably Kubernetes, to manage and scale all those services, and service discovery so they can find each other dynamically. It's a lot of upfront infrastructure thinking, and this is the huge payoff you get, deployment independence. Teams can update and deploy their service on their schedule. Think about Spotify. Their search team can push updates multiple times a day. They don't need a meeting with the playlist team to do it. That enables really rapid, independent feature releases.
Okay, what about scalability and resource efficiency? That seems like a big driver. With the monolith, you scale by just copying the whole thing. Even if only, say, image processing needs more power. Seems wasteful. Higher
That
costs, probably.
It often is wasteful, yeah. You end up over-provisioning resources for the parts that aren't busy. Microservices, though, let you do targeted scaling. User authentication getting hammered, just spin up more instances of that service. It also lets you optimize resources better. Maybe one service needs a lot of CPU power, another needs tons of memory. You can put them on different kinds of machines optimized for those needs. Can't really do that easily with a monolith. So yeah, microservices generally win on scalability and cost efficiency at scale.
And fault tolerance, resilience. How does that compare?
Big difference here, too. In a monolith, because everything's so tightly coupled, a relatively minor issue, like a memory leak in some obscure feature, could potentially destabilize and crash the entire system. High risk. Microservices, on the other hand, are often designed with resilience in mind from the start. That distributed nature allows for strong fault isolation, using things like those circuit breakers we mentioned. So if, say, the recommendation engine on an e-commerce site fails, the circuit breaker trips, stops requests going to the failing service, maybe returns a default response. Crucially, users can still browse, add to cart, check out. The failure is contained. A core functionality remains available.
Got it. And the last big comparison point,
Right.
Data management and team structure. Monoliths usually have one big shared database, right?
Yeah.
Simple at first for consistency.
Simple initially, yes. Easy to do transactions across different data types. But it quickly becomes a major bottleneck. Everyone's hitting the same database. Schema changes become scary because they might break something unrelated. Microservices generally push towards decentralized data management. Each service owns its own database or data store. This avoids the single bottleneck. It also lets teams choose the right kind of database for their services needs. Maybe a relational database for one, a NoSQL one for another. And this ties directly back to team structure. It reinforces that move away from functional silos towards those small, autonomous teams having full ownership, data included, really boosts accountability and efficiency.
Okay, all these comparisons point towards the real question. When do you actually choose one over the other? It's not just tech specs, it's about the business context, right?
Yeah.
What you need now.
Exactly. Where are you starting? Where do you want to go? And who's on the bus with you? And despite all the excitement around microservices, starting with a monolith is often, honestly, the smartest initial move, especially for new projects, new products, or things with a pretty well-defined, limited scope. That initial simplicity gets you moving fast, keeps initial operational costs lower. The classic case is a startup building its MVP. Small team, tight budget, main goal. Get something working in front of users fast to validate the idea. For them, a monolith offers that critical speed to market. Build, test, ship without getting tangled in distributed systems complexity. It means lower initial costs too. No need for heavy investment in infrastructure or specialized DevOps tooling right away. And development is unified. One code base, easier debugging, simpler for a small team to coordinate. Think about early Etsy. They launched as a PHP monolith. It let them focus purely on core features, building their community. Only later, when things got much more complex, did they start strategically breaking it down. So if your immediate priority is speed and validation, a well-structured monolith can be a real strategic advantage.
That initial speed is tempting. But yeah, keep thinking, what happens when it works? When the app takes off? When you need to scale massively, keep innovating rapidly with multiple teams. That's when microservices start looking much more attractive, isn't it? They really shine when you're dealing with serious scale, growing complexity, and that need for different teams to ship features independently and quickly. It feels tailor-made for large, evolving systems where you just can't afford one small glitch taking down the whole show. Like that big e-commerce platform example again. Handling huge Black Friday spikes while constantly adding new features. Microservices give you a path. Independent scaling. Boost just the payment service for the sale. Don't touch the product catalog. Saves money. Team autonomy. The search team owns search. The inventory team owns inventory. They deploy updates whenever they're ready. No monolithic release train. Way faster development. And enhanced resilience. If the recommendations engine hiccups, oh well. People can still search and buy. The core business isn't impacted. Netflix is the poster child, starting that migration way back in 2009 to handle insane growth. Thousands of services, thousands of deployments a day now. DoorDash is another well-known success story of making that transition work. Okay, so this whole debate, monolith versus microservices, It's really not a one-time pick one and stick with it choice, is it? It sounds more like an evolutionary path. The decision today depends on today's goals, team skills, future vision. The key seems to be cutting through the hype and figuring out what you actually need right now.
Couldn't agree more. And making that call means asking the right questions. It's not a rigid checklist, more like a framework to guide your thinking. First, what's the immediate business goal? Are you rushing an MVP to market? Monolith probably makes sense. Are you re-architecting a huge, tumbled system with many teams? Microservices look better. Second, what's your team's expertise? Small, co-located team, maybe newer to complex systems. Monolith is easier to handle. Got strong DevOps skills, experience with containers, distributed systems. Microservices are feasible, but they can overwhelm an unprepared team. Third, application complexity. Is it relatively simple? Monolith is likely fine. Is it a complex domain with lots of distinct functions? Microservices can help manage that complexity by breaking it down. Probably the best advice for many new projects. Consider starting with a well-structured monolith. Think about modules, clear boundaries inside that single application. Then you can evolve towards microservices later if and when the complexity and scale demand it.
Right, that modular monolith idea. Build one app, but keep the internal parts nicely separated. It gives you that initial speed, but makes a future migration to microservices much easier if you need it. You can sort of peel off modules later. And it's worth mentioning architectural trends too, right? The industry is getting smarter about the trade-offs. People are talking more about the majestic monolith or modular monolith, building a single app but with really clear internal boundaries, giving some of that ownership benefit without all the operational overhead of distributed systems. We're also seeing a lot of hybrid models. Start monolith, gradually carve off critical pieces into microservices as needed. Ultimately, yeah, the architecture should serve the business needs, solve today's problems while keeping an eye on tomorrow's challenges. So as you're weighing all this up, a few common questions always seem to pop up. Let's tackle a couple.
Yeah, happy to. A really common one is, can I switch from a monolith to microservices later? And the answer is a definite yes. In fact, it's often the recommended way to do it. There's a well-known strategy called the strangler fig pattern. Martin Fowler coined that term. The idea is, instead of trying a risky big bang rewrite, you gradually build new features as separate microservices around the old monolith. These new services talk to the monolith. Then, over time, you carefully migrate existing functionality out of the monolith, piece by piece, into new services. Eventually, the new system strangles the old one. It's much safer, allows incremental modernization, keeps the lights on while you do it.
Okay, that makes sense. Incremental is usually less scary. Another big one. Are microservices just plain more expensive than monoliths? Seems like all that extra complexity orchestration monitoring must cost more, right?
Well, yes and no. Microservices typically do have a higher initial investment. You need to invest more upfront in DevOps, tooling, CI/CD pipelines, container orchestration like Kubernetes. Your infrastructure setup is generally more complex than just running a single application, and you absolutely need better monitoring and observability tools to track requests across services and figure out what's going wrong when it does. So, yes, upfront costs are higher, but the argument is that microservices can become more cost-effective at scale. Why? Because of that targeted scaling. You only pay for the resources you actually need for each service, reducing the waste you often see with scaling entire monoliths.
Gotcha. Higher initial setup cost, potentially lower running cost at scale due to efficiency.
That's the trade-off, yeah.
And lastly, how does this choice affect team structure? You touched on this.
It's a huge impact. It's not just a tech change, it's often an organizational one too. Microservices align almost perfectly with that two-pizza team idea from Amazon. Small, autonomous teams owning their service cradle to grave. It fosters end-to-end responsibility. Build it, run it, own it. That's a pretty stark contrast to traditional monolithic development, which often has larger teams, functional silos, front-end team, back-end team, database team, and slower handoffs between them. So moving to microservices often requires rethinking team boundaries and responsibilities just as much as the technology.
Okay, so wrapping this up then. The choice between monolith and microservices isn't static. It's dynamic, it's strategic. It's really driven by your unique project context, your team's capabilities, and where you see things going long term.
Exactly. And hopefully by understanding these trade-offs, the pros, the cons, complexities, you feel more empowered. Empowered to make choices that really fit, whether you're just starting something small or scaling up something massive.
Absolutely. Now, for your parting thoughts, something to chew on. Think about a system you use every single day. Could be your favorite app, could be some huge enterprise platform you use at work. Ask yourself, is this thing likely a majestic monolith, humming along as one piece? Or is it more like a hidden symphony of microservices, all working together behind the scenes? And how might that underlying architecture, that fundamental choice they made,